Okay, everyone. I'm Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. This is a live session 3, it means assignment number 3 for a design of photovoltaic system. The third session related to the sun power. Actually, what is the sun power for the engineering and how it convert to the electrical power. It means the irradiation and insolation, all of the thing, and what is the zenith angle and latitude and different thing, and how we affect the how the angle is affect to the electrical power in a solar system. Solar system, it means sun. If you take the sun, irradiation, this is our photovoltaic system, our PV model. This is the out our PV model. You can use a PV model. We model convert the solar energy to the electrical energy. After converting electrical energy, you can use batteries are charging and other storage system like hydro storage and compensated air storage, flywheel storage. Hydro storage means if sun is and the daytime sun is there and solar energy is there, solar energy connect to the electrical energy, and by the pump, solar pump, you can store the power, sorry, store the water at any storage system, water storage system. When the off time, the solar sun is not present, you can use that power for the hydroelectric energy to convert to the electrical energy later. This is the hydro storage system. You can use it for the two types. You can use it by a converter, power conversion, and second one for the storage system. Same is the flywheel storage. And sun is present, electricity is generated, then you can store the energy in flywheel by using spring. And when present energy is not present, solar energy, that time you can use the spring, lose the spring, and the motor is run, and motor is connected to the generator. That flywheel connected to the generator will be develop the energy. Same thing, you can convert the energy from one farm to another farm. But what is the efficiency? All of the solar power, solar energy converted to the electrical energy, or some there is some efficiency. It will not definitely it will not be 100% energy converted. It's some part of energy will be converted, like 50% or 20%, maximum 30% energy is converted in the electrical energy only. Efficiency, you know, the if PV cell output power divided by input power. Output power is maximum MPPT. All of you know about the MPPT, maximum power point taking, maximum power point taking. P in the insulation, radiation, into area. But the insulation is depending on the sun radiation, sun orientation. Suppose you have a plate like that, same as the solar plate, solar PV system. This is the normal to the surface, but when sun is like not always normal to the surface. Sun is different at a different way, different time, because of the rotation of the earth. Earth is rotated from west to east. That's why the angle also change. Suppose sometime angle is there, this is the insolation or sun radiation. If you take this angle is a theta, then what is the insulation? L will be converted in the, you can say, incidence power. This one is the normal to the surface. This will be, you know about in triangle. This one is theta. Take this one as xy axis. All of you know. Now this one is the x is the, if you take this one some point like P, and this one is the P cos theta, and this one is the P sin theta. Same thing you can apply here. The side of the angle is the cosine. This one is the Li sin theta. Sorry, Li cos theta. The normal to the surface is the Li cos theta. It is depending on the angle of the theta, the irradiation angle. What angle sun is staggered at the PV panel. Then L can be written as the Li cos theta. Will be written as Li cos theta depending on the angle, incidence angle. Then what is the power output? Power output is to take as efficiency to Li cos theta into area. This is the actual output power of the solar PV system. But you know the spectral irradiance we measure in the, like a kilowatt per meter square plus wavelength, unit wavelength. The wavelength you can say like intensity of the light. It will be different type. Ultraviolet rate, sorry, ultraviolet you can't be see by the wear our eyes, and visual rays. Another is the infrared. Infrared wavelength is very high. It means the frequency is very less. You can the intensity is less, but for a long time period you can see this one. So when we categorize in three tone, that graph is approximately this one, like that. Spectrum radiation of this one is a solar spectrum, which means light density spectrum. We categorize in 3 port. This one is the ultraviolet. UV rays you can't be see this one, and another is a visual wave. You can see by your eye. Another is an infrared. This is categorized by the wavelength, depending on the wavelength. Lambda, the wavelength in nanometer, so very small. So 400 to 700 nanometer, you can visual. You can see this one, this light by your eye. After this one, 700 to like approx 2000 something, coming in the infrared. Sorry, but power is not developed in infrared. Only in the visual is the power is high. You can say this one is power of so, spectral and radiance. Spectral radiance means given in the kilowatt hour. Sorry, kilowatt per meter square per unit length. This one categorize is this is in PS. It means a kilowatt hour. Sorry, kilowatt per meter square plus wave per wavelength. 0.5 1. This will be 1.5. I think maximum is 1.5 prox 1.5. So 2 kilowatt per meter square per wavelength length. If you want to calculate the insulation L which is in kilowatt per meter square, then you can integrate all of thing. It means if you integrate a spectral radiance with respect to lambda, you can find the average of the the total irradiance, total insulation of the solar rays. It will become in like starting from 0, it will become go like that. It will be 1.37 something kilowatt per meter square. Average of this one. But this will change with respect to the time in daytime. This will be the a single wave, single rays, and the sun. If the sunlight is there, then this type of wave is generated by the sunlight in every time, so morning to evening and the daytime. It all of wave, ultra wave, visual wave, infrared. But depending on the this intensity, the power will be developed. And if you talk about the in daytime, like 12 p.m. Or 1 p.m., the maximum power developed. At that time, the this power is going beyond that. It means if you want to draw same spectrum for a daytime, this is lambda, this one is PS. If you want to draw a power insulation like L, it will be depending on the daytime. This one, sorry, this one morning 6 a.m. This was the maximum at 12 p.m. Same thing, this one is repeated 6 a.m. to 12 p.m. is the maximum. After that 1 p.m. this one reduces at the 6 a.m. and 6 p.m. like that. In night wave, this one will be 0.
That is very helpful.
This one will be 0. Now you know about the insulation is be power developed by the solar is like that. Sorry. Respect to time, maximum power is developed at 6 a.m. to 6 p.m. and this will be the at noon. Maximum power is developed. If you want to calculate in the kilowatt hour as energy, you want to calculate as energy, then multiply by the hour. This one, H. Then it will be kilowatt hour per meter square per day. In one day, how many energy is developed by the solar system? You can calculate by multiply the hour. But this is the affected by the many of term. The solar power affected by a many term by like factor affecting geometrical geometrical, you know, the places location, and different type of location is different power is developed. Like if you want to talk about the polar at a pole of the north and south pole, the power is generated is minimum at 0, approx 0. It is depending on the latitude and longitude. Is with the you can say factors affecting our irradiance. Also you can say energy, that's energy affected geometrical location, uh, longitude and at latitude. In orientation of the panel, you can say like a panel orientation, flat or curve like that. And time after day, hour, in morning, noon and evening, like that. And time of a year also they affected, like in winter, summer, rainy season or cloudy season, depending type of atmospheric condition is coming the clouds. Like the earth solar cell, it will looks like this one be sun. This is a rotation of the earth, orientation of the sun. This will be earth on the March 3rd, in March, and this will be in summer type. This will be in winter time, winter season, and this will be in September. Winter season it means December, summer June it means June. Maximum is the 21st, 20, 22, 23 like that. March also 22, 23 March. September also 22, 23. Like 21 is the most of the things will come in the one way, so known as the equinox. Equinox way, like equatorial plane. The different season, different power will develop. This one in the winter season, power will develop I think 1.41 kilowatt per meter square. It is insulation, and at summertime it will be reduced, I think, 2.33 kilowatt per meter square because of the heat. Also develop the heat. Oh, sorry, heat is depending on the solar panel, but it is only developed by the solar only. It is depending on the angle, and this will be, I think, 1.36 kilowatt per meter square, and this will be 1.38 kilowatt per meter square. This will be approximately same. At winter's time, the maximum solar energy developed. The declination angle is important in the development of energy. Declination angle depending on the season or depending on the year, month, day, type, time of the year. Which day it is depending on the solar system of Earth. Like this is 2.23.5 degrees centigrade. Sorry, degree orientation of the Earth. That 2 point solar radiation is like this one. Declination. You can say this one is the declination angle of delta. It will vary from the here to here. June to December. Maximum power is developed here. So this one is the equaplate, equinus plate, I think. Equator. This will be same point at March and September. At March and September, both are the same point, and this will be June to December. It will vary from March to June. After that, it turn path like that. So the angle will be changed 0 to 233.5 to minus 233.5. You can say up, or you can say this one is north, this one will be south. Earth is rotated from like that to west to east. This way, this in declination angle we defined as 23.45 degree into sine 2 pi n min minus 80 divided by 365, where n is the number of day. Like n is equal to 1 at January 1 and n is equal to 365 at December 31st. This type of thing. You can define the angle of the declination angle. Then different type of angle is defined in the solar system. You should know about that. Like declination angle and hour angle, zenith angle, and what is zenith? Zenith angle is the declination from the angle in the insolation line and the normal surface line. Surface to normal line. This one the east axis. This one is the polar axis, and another is the meridian axis. Divided by m. 3 the centric point of the earth. This one is the center point of the earth. You can say this one is the earth centric point. At the center of the earth, then what is the effect of the sunlight at different season and different time? Then how will be defined? If we take a part of this one, I will take this a part of this one. And a declination angle, like in, you can say this one insulation line. The declination answer is depending on the projection of this one at the surface. What is the angle made by them is known as the declination angle, delta. And from the meridian action, this one will be the over angle omega. Omega define the time and the day, day angle, and the delta is defined the season here of month and day angle, which one day is come like 1st January to December 31st, and omega is defined the angle of hour. It means that this one is east, sunrise in the east and sunset is the west. The sunrise is that point, and this angle will be changed, like at the sun's rise this angle will be 90°. This angle meridian axis and east axis both are in 90°, and polar axis and east west is also 90°. All of thing is placed in at 90°. That's why at sun's rise the omega will be 90°, because of the insolation occurs at that point. Delta will be 0. Oh sorry, this will be this point, this will be same in the morning time or sunrise time, that will be 90°. It and the but it will depending on the delta also. If delta will be 0, that time it will be accurate 90°. But if delta is not 0, delta is vary from 23 0 to 23.5°. It will be depending on the season or day of the year. If delta is 0, then omega is exact equal to the 90° at sunrise, because of this one is be same at this type point when delta will be 0. But delta will not 0, then it will be not equal to a 90°, a maximum angle. In the 3D system also, in xy plane, and you can x, y and z plane, if a point is there somewhere, we want to draw, then you made a projection of this one projection of this one at a normal surface. If this angle will be at that time this angle will be delta, and this will be omega depending on the hour time of a day. This will be vary from here to here depending on the delta time also. This is the projection, that is the same as this one. This one is projection of insulation line. This one at the projection to that point is the delta, and this point is meridian line to the projection line is the omega, and you can relate the 3D point xyz axis. This one is the point, and projection of this one is the normal surface. So that plane horizontal surface, this one, this will be vary from the angle of omega. It will depending on the hour time of a day, and delta depending on the day of the year. Okay, omega and delta will be defined. Delta is the inclination angle. It will be depending on the day of year, and omega is the hour angle in a day, hour time. This is, you can say, earth centric point. This will be at that center point, but you want to calculate at the surface of the earth. What is the all of thing at the surface of earth? This angle is made by the earth center of the earth. The same thing, if you want to define as the surface of the earth, then you can take a surface, normal plane surface at the earth point, and then another axis will be defined here at the center to the normal to the surface. Axis is defined as zenith axis. Zenith axis is the central normal to the that surface, and the combined to the center of the earth also. And from here the 90 degree of east, same thing I have taken as the east, and this will be south. Tangent of the earth is known as the south, and if you want the same insulation is at that time the zenith angle will be defined from zenith axis to the insulation line theta z. This will be L in insulation line. It will be defined from the zenith axis to the insulation line, not insulation line to the zenith axis. It will be different because of sun is rising at that time east, and sun is set on the in the west. At that time z will be theta z will be vary from 0 to 90 degree and 0 to minus 90 degree, you can say. A maximum degree will be 90 degree. And the angle between center point to the median axis is the phi. And same thing in the 3D axis, the projection of this one is come on the surface, and the from the south, like same as the omega, our angle is defined as this one is the azimuth angle, yes. I guess same as the our angle in the at the surface, but the projection of the insulation line to the horizontal surface, and after that the angle between them and to the south surface is same, is the azimuth angle. Theta z is the zenith angle. And this one is the local surface, local centric coordinate system, you can say. I define again here. I am defining the two different coordinate. First one for the local centric coordinate system, it is the top of the surface, at the surface of the earth, and another is the defined at the center of the earth. The first follow local coordinate system, I'll take like this one is the east, same as this one is the zenith axis, another axis is the south axis. How to calculate a zenith angle? Okay, wait, I will explain later. This will be the zenith angle. Same you can relate to the third coordinate like that. If insulation is a line is there L, the zenith angle is defined from the zenith axis to the insulation line. This angle will be known as zenith angle, and the projection of this one as the horizontal surface is there, and this angle from the south angle is known as the YS, azimuth angle. Then how to calculate that overall insulation of the surface? This insulation time. Insulation time you can calculate by the angle or by the date time. Wait, I explain this one first. This one LE you can say. This one is zenith axis, LZ. This will be L, LS. The overall in L will be defined as the south insulation and our east insulation and zenith axis insulation. Total of this one. Then what will be the south insulation? This one. This angle will be theta z. Then this will be LZ will be L cos theta z. Okay, see first one I written LZ is L cos theta z, and L, and this is be the, if you take this one L dash will be L sin theta z, because of this is, and this is the same. This is at the 1090 degree because of this one is the surface, plane surface, horizontal surface of Z1, and this one will be at a 90 degree. Then this will be the theta z, then remaining is the 90 minus theta z, then L will be a L sin theta z at the L dash of this one. If this one is the L in sin Z, then what will be the LS? LS will be cos L sin theta Z into this angle. We define as the cos of YS. Same thing. This one will be IYS. This will be replaced from by 90 degree. Then will be L sin theta Z into this will be the sine of azimuth angle YZ. This is for the local centric coordinate system. Second is the centric or centric coordinate system. This one polar axis and this one is the meridian axis. So insulation of L, this one is theta, then this one is L, this will be omega. Same thing, this we can say this one is L dash. Then same phenomena occurs here. L is LM plus LE plus polar insulation. This insulation, this will be. Then what is the LE? L is same as the L cos delta. Oh, sorry, delta is not from L, this is from this one. Is called delta. This one is an L dash cos delta, and this one is the. After that, this one is replaced by the 90 degree, and this one is angle is omega. This angle is 90 minus omega. Then L cos delta and sin omega. Same thing. LM is a L so cos delta into sin. Sorry, cos omega, because of this angle is related to this one. And next one is LP. LP is the L sin delta because of this one. This is the replaced by the 90 degree, and this one angle is a delta. Then this angle is a 90 minus delta. Then this insulation L respect to the polar point is the L sin delta. Both are defined as this one the center local centric coordinator, this one the earth centric coordinate system. Then combined of this one, then find the final insulation of the system. You can see here the E, small e and capital E both are at the same point because of the east, denoted the east. I can this one is the east, both point at the same, and east same 90 degree is the P polar axis. This kind of had local system is the zenith angle is z, and this will be the south, the 90 degree. So my radian point m, this angle from meridian axis to the zenith axis is the phi. So insulation is there L, the relation between Lm, we say this one the LP, this one will be the LZ, this one is the LM. Relation between these all of T, you can say that L of the zenith axis is Lm cos phi plus Lp sin phi. Lm and Lp is defined here, we can put there, and Lz is equal to Lm cos phi. Lm is the L cos del into cos omega into cos phi plus Lp. Lp is the L sin del into sin phi. Lz is the L of cos phi z. Phi z is the zenith angle. Then from here you can calculate the zenith angle. L will be cancel out all of, then you can calculate the cos phi z. Cos phi z is cos del into cos omega into cos phi plus sin del into sin phi. And what will the zenith angle? Zenith angle is be cos inverse of this one, cos del and cos omega into cos phi sin del into sin phi. Where phi is the longitude angle, sorry, latitude angle. It will have the place where you place the solar system. Delta, you know, declination angle of insulation. Omega is the hour angle. It will depend on the time of day. By for a calculation of hour angle, you should know about the overall power. After that, you can calculate the hour angle. By daily energy, because of the hour angle is come on the day, and in a one day how much energy will be generated. From there you can calculate the hour angle. First of all, calculate the overall energy of a day. Then how will calculate this one? Know about the morning to evening. So power graph like that. Insolation and sun is rise. This will be sunset. This will be noon time. In the insolation at the normal surface of the plane, horizontal plane. Then calculate the area of this one. You can find the overall energy of this one. From that you can say H naught integration of Lz with respect to a day time, a day hour is the omega. Omega depending on the time of hour, time of day, or you can say the hour angle. If you integrate off of the thing, then you can find the overall energy. You can say a kilowatt hour per meter square per day. Lz we can calculate here. This one will be the Lz, L cos phi, cos del cos omega into cos phi plus L sin del into sin phi. Integrate this one is respect to omega. Omega is one only, one term. You can integrate this one. After that, to find the total energy of this one. You can see here, this will be the omega angle. This will be the east where the sun is rise, and here will be the west. The sun is sunset. You can say sunset. This angle is be omega. When sun is rise, we can say this will be the omega sunrise SR, and this will angle is the omega sunset, omega SS. But at that this angle is represented in a negative term, and this whole angle is being represented in positive term. Then you can say if sun time is represented to the omega SR, and same sunset is represented the minus of omega SR. And you can say this SR will be same as minus of omega SM sunset. That's why if you want to integrate the whole time of energy Lz from sunrise to omega sunrise to omega SS sunset Lz into cos Lz into d omega, and you can say this one is minus of omega SR 2s omega SR. You can say this one. Sunrise to sunset or sunset, so to write with one of the same time period, and you can calculate this one, where Lz you can put the value of Lz. Yeah, you can say as this one will be 2 times of 0 to omega SR Lz into d omega. Put the value of Lz and integrate this one, then you can find this will be a 2L of cos del into cos phi into sine omega SR plus of sine del into sine phi into omega SR. Because of this one is the constant term. This will become into kilowatt radian per meter square plus per day. You can change the radian into the hour, then pi radian is equal to 12 hour because of the day time. Then omega radian is 12 by pi into omega. This will be coming in the hour. Then you can multiply up this one. Then you can find H naught is equal to 2 into 1 to 12. It will be 24 by pi into L cos del into cos theta cos phi into omega SR sin del sin phi onto omega SR. The total energy in one day. For calculation of the omega SR at the sunset, sunrise, at the sunset and sunrise, radiance will be 0, insolation will be 0. You can say this one at point of sunset, sunrise and sunset, the LZ will be 0. Now put the value of LZ, overall energy will be 0. Then you can find the omega SR. Okay, this one is the energy of this one, where L denoted is the solar constant LSC is the standard of for the solar radiation to find insolation of solar. Same thing, 360 N divided by 365, where N is the number of day, 1 for January 1 and 365 for December 31st. To calculate the sunrise and sunset angle, then what will you do? Like you know about LZ is equal to L sin L cos del L cos theta z zenith angle is equal to L cos del into cos of omega into cos of phi plus L sin del into sin phi. L will be cancelled out to find and calculate this one angle cos omega. At sunset, sunrise, LZ will be 0. Sunrise will be cos inverse of minus tan del into sin tan phi. We'll calculate the sunrise angle. Zenith angle will be calculated by the this one. Can calculate zenith angle from here, and we will calculate the sunrise and sunset angle. Sunset same thing, minus of omega SR from here. Take the question for that. The output of the PV cell is 2 watts at an insolation of 1 kilowatt per meter square. P output is given 2 watt. Insolation is given as 1 kilowatt per meter square. Area is also given 150 cross 150 mm square. It means it will be 0.15 to 0.15 meter square. Efficiency is given 50%. Angle of incidence radiation with a normal solar cell will be oxygen. This will be same thing. Can output power related to the efficiency and Li cos theta into area. Can use this one. P output is Li cos theta into area into efficiency. All of thing is given. Now asking about the theta angle. Now if the theta angle is cos inverse output power divided by irradiance insulation and area into efficiency. Output power is 2 watt. Li is 1000 meter per 1000 watt per meter square. Area is 0.15 into 0.15 into efficiency is 50%, means 0.15. If you calculate this one and you find is cos inverse 2 by 3.375, it will be 53.65 degree centigrade. Sorry, degree. The value of solar constant is approximately LSC solar constant. Then here this will be solar constant. Solar constant is same as 1.37 kilowatt per meter square. This will be the out of atmosphere of the Earth. This is radiation. And solar insulation is the out of the atmosphere to Earth. That's why it will be 1.37. 1 kilowatt is the atmosphere and at the surface of the Earth. In the standard 1 kilowatt per meter square. This will be the solar constant. Solar constant is with the above the atmosphere of the Earth. The sensitivity of solar cell to the expected irradiance of sunlight is maximum at the wavelength 400 to the 700. The less than 400 is the ultraviolet wave. Spectra is the ultraviolet. 400 to 700 is the visual, and 700 to 2000 it will be the infrared. That will be asking about the maximum power. Solar spectrum irradiance is the maximum at the 400 to 700 will be visible power. I think this will be nanometers will be in nanometer to the 400. 0 to 400 is ultraviolet, it will be not visible and not more. The power is developed here. More power developed in visible condition. At the given point on the Earth, if the solar declination is minus 20 degree, hour angle is 45 degree, and latitude is 30 degree, then zenith angle. Know about the L insulation. L of cos phi is equal to L cos del into cos omega into cos phi plus sin del into sin phi. For the find the zenith angle, we take this one, it will be cancel out. Cos phi z is equal to cos del into cos omega into cos phi plus sin del into sin phi. Value is given as the solar declination angle. Declination angle is minus 20 degree. And our angle is omega is 45 degree. And latitude is phi, latitude angle is 30 degree. So put the odd value and find the phi z. Cos of minus 20 degree into cos of 45 degree into cos of 30 degree plus sine of minus 20 degree into sine of 30 degree. Let's calculate this one. It will be 0.404, and phi is equal to cos inverse of this one, zenith angle 0.404 is 66.144, approx you can say 66.15 degrees centigrade as well degree. The solar declination angle is given 20 degree. 20 degree it means this one will angle is be negative at the here. This one will be June, will be December, will be March and September. In December, September to December, between September to December will be the season there, negative of declination angle. At sunrise and sunset, the zenith angle. Center of the earth. At a surface of earth, take a plane surface, draw a line normal to the surface. This will be the zenith axis. This will be east. This will be south axis. Insulation axis, insulation line L. The zenith axis to the insulation line known as the zenith angle. That thick. This is very east to west, and in the east sunrise rise, sunset will be in the west. This will be maximum angle going, I think here will be 90 degree. Zenith axis to the east axis is 90 degree. That's why a maximum angle will be go at the sunrise. Sunrise is here in the east, and this angle will be goes to the 90 degree. It target as rise time. Same thing in sunset. It will be also sunset measure from here. Same thing you can say is 90 degree. Maximum is the west point. That's why sunset and sunrise time is zenith angle will be 90 degree. Not given as the minus 90 degree. That's why you can say it's a 90 degree. This angle measure from the zenith angle. If you measure from the here insulation line, take a point. If the angle is measured from the insulation line, at that point at the sunset, it will be the pi 90 degree. But if we measure from here, the if sunrise, sunrise is 90 degree. Sunset it will be the minus 90 degree. But the angle is measured from the zenith angle to the insulation line. This angle is measured zenith angle. The length of the day will be approximately 12 hours on the exactly 12 hours day and night. It will be in equator point. Equator point means the sun. This point is the equator point. Equator point means the same point, equatorial axis. This will be the September 21st, yeah, to say 20 to 23. I think it's very taken. This one is March, this one September 20 to 23. This will be the December line. This one is the June. Equator line, this one. At equator line, the day and night is the same. That's why we take the day will be approximately 12 hours. 12 hours. That's the equator point. Yes. When the angle of declination is 0. The angle of declination at the equator point is 0. That's why the B option also correct. Because of you could say here you can see this. This one is the equator point. This one is June. This one is December. At delta is equal to 0 at equator point is the same as the March and September. March 21 and September 21 declination will be angle will be 0. At that time the day and night time will be same. It means that 12 hours approximate. So A and B also correct. No, this one will be the June time. Daytime is more than the night time. If the solar declination is the 25.5 degree, 23.5 degrees, and latitude angle is 45 degree, then the sunrise hour angle. Sunrise and sunset, you know, LZ is equal to zenith angle phi z is equal to L cos of del into cos of omega into cos of phi L sin phi sorry sunset and sunrise Lz will be 0 and this will be a 0. At that time our energy will be not generated. So cos del into cos omega to cos phi this is omega is depending on the hour time. This will be the sunrise time. You can say this SR cos of omega SR is equal to, you can say written like that, cos delta to cos omega SR into cos phi is equal to minus of sin phi to sin del cos of omega R is equal to minus of sin phi to sin del divided by say sin cos phi to cos del. This will be minus of tan phi and tan del. Then omega SR is equal to cos of inverse of minus tan phi into tan del. Declination angle is meant delta is given 23.5 degree and the latitude angle is phi 45 degree. You can put here minus of tan 45 5 is 1 into tan 23.5. You can calculate this one. This will be 1115.770. The terrestrial isolation on the March 27, 1989 is the terrestrial insolation, L is equal to L solar constant 1 plus 0.033 into cos of 360 into n divided by 365. N is the number day of year. LSC is the constant value, solar constant 1.37 kilowatt per meter square. Then calculate the number of day n. March of 27, it means January is 31st, February is 28, January, February and March. March is 27. Calculate out of thing. 8 plus 7 is 15 plus 1 16. 6 will be 1 4 4 8, so will be 86. Then LSC is will 1.37 kilowatt per meter square into 1 plus 0.033 into cos of 360 into n is 86 divided by f 365. This will be 1.3748. This will be approximately this one. This one 1.33, 1.38, 1.34, 1.3747. Okay, on which day zenith angle will be equal to latitude angle? Zenith angle is same as the latitude angle. One 1.3741. Okay, you can say this one 1.3708. You can take as approximate 1.3741. It will be same. Maybe option will be mismatch. L is L sin, sorry, L cos phi z is equal to L of cos z cos del into cos omega into cos phi plus L of sin del into sin phi. Then on which day zenith angle will be equal to latitude angle? See here, this will be the L cancel out of this one cos phi z cos del into cos omega into cos phi at noon time. The hour angle will be z will be approximately 90 degree. Oh, sorry, 0. If we take this one, then it will be cos phi z. If we take at noon, it means that omega will be 0, then cos del and cos phi plus sin del into sin phi, and cos phi z will become as a cos del minus phi. Cos cancel out, phi z is equal to del minus of phi. We take a model of this one, you can be exchange this one is phi minus j del or del minus 5. That's why. And the question is asked about the what the on which day zenith angle will be equal to the latitude angle. It means zenith angle this one, latitude angle this one. It means inclined angle will be 0. Declination angle 0. If a declination angle will be 0, that means the zenith angle equal to the latitude angle. Ask the September and March. March 21 and September 21 is the same as an equator point. At equator point, zenith declination angle will be 0. You can see here this will be June. At June an angle is 23.5 and December 23.5 is the north and south, and at equator a convex plane, it will be the March 21 and September 21. Yeah, 20 to 21, 20 to 23, 2 to 3 days margin can take. Thus at that time the angle will be 0. A declination angle will be 0. At a declination angle will be 0, this means the 5z is equal to same as the pi latitude angle. It will be the March 21 and September 21. At a June, no. At a June 21, it will be declination angle will be 23.5. On what day approximately the sun will be overhead at means noon at the place located on the latitude of 8.57 degree. Latitude angle calculation formula is 23.45 sine 2 pi n minus 80 divided by 360 degree. So it's 365. Same thing apply. N is number of date at January 1st, n is equal to 1. At December 31st, n is 35, 365. This angle is given as 8.75, 8.57. Then calculate the n first, calculate the number. This will be the degree. Okay, this will be in degree, this will be also in degree, but the number of this one is be not degree, this will be in radian. 2 pi is given. That's why calculate the this one into first of all, or to calculate into radian or calculate all of into degree. You will sine 2 pi n minus 90 as 8 minus 80 divided by 365, 8.57 divided by 23.45. And 2 pi n minus of 80 divided by 365 is equal to sine of inverse 8.57 divided by 23.45. This will mean radian. That's why this will be the angle you can calculate in radian by multiply a pi into 180 degree. Pi cancel out. Calculate number of n from here. You will find 102. 102 means January, February, March, January 31st, February 28th, March 31st, April. These three will be 90, remaining up 12, I think. 192 minus 90, it means April of 12. Okay, this one. Okay, everyone, I am stopping here. Thanks to all.